Welcome to the second episode of Science with Rachel. I'm Brennan.
I'm Rachel. Today we're going to talk about a topic that is used in physics and chemistry, the 4 laws of thermodynamics. We actually started with 3 laws originally, and then they came up with a 0th law because they came up with something that they thought needed to be added.
Why couldn't they add a 4?
Because apparently it was more important than the first one, so it needed to be 0.
Is 0 more important than 1 though?
It's more fundamental. You can't divide by 0. You can multiply by 0.
Let's check out the 0th law.
The 0th law is a basic idea of the transitive property, which seems like common knowledge. Thermal energy of system A is equivalent to the thermal energy of system B is equivalent to the thermal energy of system C. By the transitive property, the thermal energy of system A is equivalent to the thermal energy of system C. The idea behind it is if A equals B and B equals C, then A equals C.
What is a system?
A system can be anything. It can be a lever, it can be a pulley, it can be the entire universe. It could
So a lever is equal to the universe.
That is not
If
what
I pull a lever, the universe happens. That was the Big Bang. Somebody pulled a lever.
So you don't pull a lever.
So every time we pull a lever, the universe happens. We'll get to that law later on.
What? The first law is that in a contained system, energy is neither created or destroyed, and it is only converted into other kinds of energy. So the idea behind this, there are 2 different kinds of energy, potential energy and kinetic energy. And kinetic energy is things that are moving, and potential energy is the energy that could be possible. If the system is dropping a ball off of a table, when you're holding the ball 3 feet off the ground, it is having a certain amount of potential energy. There's a certain distance it can fall. Once you drop it while it is moving, it has kinetic energy. So in that system, you don't lose any energy. As it's falling, it is changing from potential energy into kinetic energy, and then from kinetic energy back into potential energy. So once it hits the ground, it is completely converted into potential energy.
So basically, another way to think about this is the system is the man. The man is trying to keep back your potential, but you got to keep that potential going. You got to make energy happen.
I'm sorry, who's the man?
The law of thermodynamics.
Because potential energy is the man?
No, the system is the man. Do you not understand?
No, the system doesn't control anything. The system is a closed entity. Energy is neither created or destroyed. All energy is converted into other energy, which means in the universe there's only a finite amount of energy, and it gets converted to any kind of energy.
But is there a finite amount
new.
if there's an infinite amount?
There isn't an infinite amount.
How?
There's a finite amount of energy in the entire universe.
Where does the universe end?
Nobody knows.
So it could go on infinitely.
No, the universe does not go on infinitely. There is a finite space that is the universe. You can't say because you don't know what the definite number is that it is then infinite.
They also thought the world was flat before.
What? That's not related.
Just because you think that something is true now doesn't mean it is true. There could be a finite amount of energy.
That's what I said, there's a finite amount of energy. Yes!
So there could be an infinite amount of energy. Even though we can't prove there's a limit, or show the limit, or even give you a rough estimate about the limit. Who can give you a rough estimate of the size of the universe?
I don't know, I'd have to look into it.
So I felt the same way when the Kinect came out. I thought it had a lot of potential, but it just didn't go through. I think that's related. Connect, potential.
Is it like the movie The Dark Knight Rises, which we thought had a lot of potential to be good, and then it just wasn't that great? Let's move on to the second law.
The second law?
Which is my favorite, and I'm sure Brennan's favorite. The second law of thermodynamics, there are 2 ideas that are big in thermodynamics. There's enthalpy and entropy. Enthalpy is energy, and entropy is chaos or disorder. The second law states that everything is moving towards, or a system will always move towards a higher entropy. Everything goes towards chaos.
But if everything descends towards chaos, why did more order come about in the universe?
Well, think about it. Evolution started with a very small amoeba, which is a very simple object.
So it got more complex.
It got more complex.
And more organized.
Not necessarily more organized.
So you'd say randomly floating gases is more organized than structured organisms?
It's simpler. Think about it this way. A solid is more organized than a liquid, which is more organized than a gas, because of the particles can move around more. So if you think about your body, like a bunch of really small particles have the ability to move around, more chaotic than this couch.
My body is more chaotic than this couch. You should see my body on this couch.
So we're talking about chaos. So what I was saying is that something like our bodies have a lot of liquid and gas in them, and not a lot of solid in comparison to things like trees or like the ground or like the earth as a whole. So the progression of life is more chaotic than like solid substances. So you are more chaotic than a tree, and you are probably more chaotic than an animal smaller than you, since you're larger and you have more mass.
Am I more chaotic than a monkey?
You're more chaotic than a monkey. Think about it like that. You're more chaotic than a monkey. So if your parents ever tell you to stop acting like a monkey, be like, I'm more chaotic than a monkey normally, so if I was acting like a monkey, that'd be a good thing.
I think they lock you up in a mental institution after you say something like that.
But it's science.
It's science. But I'm only here because of science. I love this white jacket. It's like a lab coat.
It makes sense though. At my family gatherings, there's always that point. It's like it's great. And everybody's having a good time. It's all organized. We're all sitting and eating dinner. And then all of a sudden, chaos. The last law is not as exciting. The third law of thermodynamics says that as enthalpy in a system goes to 0, then the chaos will also go to 0.
Oh, that's moving away from chaos. I just disproved thermodynamics.
Anyways, quiz time with Brennan. Let's look at a chemistry type of scenario. So if you have a reaction, reactions can go both ways, and it depends on which one is preferred, which products are preferred. So there are 6 moles on one side of the reaction versus 2 on the other.
Let's think about this. So you have more moles on one side.
Yeah, that's more chaotic.
I mean, if I was in a room with 4 moles, that would be way more chaotic than 2 moles. If I had 2 moles, I could like keep track of both. But if there were 4 moles, they'd just be all over the place. You'd be like, oh, okay, I see all 4 moles. There's a mole, and there's the 2 others. And you look at one of the moles, and there's only 3 left. Where'd that 4th mole go? I don't know.
So you lost a mole.
So basically, I've lost a mole. What are you gonna do when you look behind you and that mole stabbed you in the back?
What kind of mole are we talking about here?
I can only think of one.
We're talking about chemical moles.
I was talking about...
Which is a unit.
I was talking about moles as in the animal.
When you're holding a ball and then you drop it, what is the process of what is going on as it approaches the ground?
Well, as the ball is falling, the gravity has potential energy in the ball. So as the ball falls, the potential energy goes to kinetic energy of moving down. But as the ball's moving down, a mole sees it, runs at the ball. It's like, I want to play. Now, this is why moles make great pets. People are like, dogs. I'm like, no, moles. The potential for fun with moles
is very high, evidently.
That's science talking, not me.
Okay.